Hello friends, this is Dr. Mohammad Aslam FCA from Pulse Tutorials. You can contact us by email, Zoom or WhatsApp for any further assistance. Today we will discuss partial least square structural equation modeling PLS-SEM with you. The PLS-SEM seems hotcake for social science research recently. It has been used widely in latest articles published in high-quality journals such as Web of Science and Scopus because it can deal with multiple variables containing multiple indicators or items for factors analysis and regression simultaneously. It is termed as third-generation statistics for social scientists. We emphasize its applicability rather than technicality and used hypothetical theory and dataset for your easy understanding. Spark PLS-3 software is used for today's discussion. Let its setup file with license key and working files link provided with this video for your download and use. Let's discuss PLS-SEM basic model building and reporting with multiple indicators. Say you found from previous literature that education costs impact on individual performance. It means earlier theory established that better education had significant impact on better performance. Appropriate reference needs to be given for this theory with citation. For example, Paul 2021. Now, we need to explore this theory either to confirm or reject with our research work and data. Here, we get two variables. One is education as independent variable and another is performance as dependent variable. In PLS-SEM, independent and dependent variables are referred to independent and dependent construct. A particular construct is observed or measured through reflective or formative indicators or items. This discussion is for reflective indicators. It means related observed indicators reflect the unobserved construct in the study. Now, we measure education as independent unobserved construct. Say, with reference to previous literature, education could be observed or measured through university education, professional education, workshop, training, and experience. In the same way, we measure performance as dependent unobserved construct. Say, with reference to previous literature, performance could be observed or measured through salary, position, job satisfaction, job turnover, and award. More indicators or items supported by literature can make comprehensive measurement for the respective independent or dependent construct. Let's assume our research is based on primary data. After setting the aforesaid indicators for independent and dependent construct, we need to prepare questionnaire for data collection. Here is the 7-point Likert scale for respondent score. Below are the two filled up questionnaire given as example for your understanding. Respondent 1, respondent 2. Respondent age 28 years. Gender male. Then they are requested to score. The first question, how much do you agree that you have university education? Score 1 to 7. The first respondent score 7. In the same way, we asked this score and they have given their response. From the score recorded in the aforesaid 2 questionnaire, we need to enter data in the Excel sheet shown below. Age 28, second respondent 34. This is gender 1 for male, 2 for female, and this is the respective score. This is the Excel data sheet and we have scored it here. Age first respondent 28, second respondent 31. This is their gender and this is their respective score. This specific format will help us to transfer data from Excel to CSV format that Smart PLS can only read. We will find that rows are taken as respondent and columns are taken as per variables indicators. This will save our effort and time. In our example, total rows 101 and total columns 12 with no missing data. Please follow the step for transferring Excel to CSV file format. It is very easy for you, you can do it. So this is our Excel sheet after fill up of 100 respondent as our sample size. Now, previously we have installed the PLS-3. This is the interface. Click new project, PLS basic. Here new project is created. I double click here to import the data. PLS basic data I have saved earlier as CSV format. I open it, then OK it. So it turns green and all the data set are here. All 12 indicators and are shown serially with no missing data. And this is our data characteristics. We can see the mean, median, minimum, maximum, standard deviation, kurtosis, and skewness. Although PLS-SEM is non-parametric test, where no need to assume normal distribution, but even we want to know our data characteristics. We know that perfect normal distribution contains mean 0, standard deviation 1, skewness 0, and kurtosis 3. Acceptable value of skewness fall between minus and plus 3, and kurtosis is appropriate range from -2 to -10 to +10 when utilizing SEM. It is deferred Brown 2006. For this reference value, we see our data are more or less normally distributed, which is the safer side for researcher. This indicator correlation gives their primary relationship, and this is the raw file exactly how we have put our data in the Excel sheet. Now we got our data set and installed it in the software. PLS-SEM basic model. PLS-SEM analysis was performed to assess the relationship between education and performance. This example studied whether education causes effect on performance. Independent constant education is measured through 5 indicators such as these, and dependent constant performance is measured through 5 indicators such as these. Our research objective was to find out whether education causes performance. So we set the null hypothesis, education, alternative hypothesis, education causes performance. Our null hypothesis is education does not cause performance. First, we prepare measurement model to check whether the model is fit for further analysis. If it is fit, then we prepare structural model to find our ultimate research objective, the relationship among construct with their respective significance level. Let's build our model with our data set. We need to double click the figure icon below our PLS basic project in the project explorer. It showed PLS basic SPLSM, which is empty canvas, look like this. Please note that this software bottom left shows indicators. This is the indicators. Now we double click here. We got the canvas. This is for design. For the time being, we delete it. This is the empty canvas. This is the indicators. From these indicators, we will take our variables. For example, we take this 5, drag to the canvas. Now we rename it education. Make it OK. Then we take other 5, drag it to the canvas, put, rename it performance. Make it OK. We align it right so it looks good. Reduce the zoom a little bit and make it align by dragging. So we got our two variables, One is education, another is performance, and this is their respective indicators. Now we connect this variable with this connecting tool from here to here and neutralize the cursor. You see instantly is turned green. It means the model is ready for run. Now measurement model. We select calculate option from PLS algorithm and select factor, then start calculation. From these we select calculate PLS algorithm. Now we select factor and then start calculation. It will take a little while. It is ready. We find PLS algorithm run 1 here. PLS algorithm run 1 for measurement model with main columns like final result, quality criteria, interim result, and basic data. Under this, we have sub columns. We find our specific required values as outer loadings, construct reliability and validity, discriminate validity. There are other things, but these things are very pertinent, so we will focusing on these. Just on this, we need to export image to our respective destination file. I have done earlier and save this. Okay, so we got this figure, which is equivalent to this figure. Now from the PLS algorithm run 1, this one, we got the outer loadings here. This is the outer loadings value. From this, we can copy from the Excel format, copy to the clipboard Excel format. So we can copy paste this like this. We copy here and we paste here. Paste here. You see, we got all the loadings value. So this is the things I have done earlier, so I'm not repeating it. In the same way, we find out the reliability and validity from here. We find out discriminant validity from here and we copy paste from there. We find out the cross-loading from here. We find out the HTMT from here. This is the way where we can directly take the data from software to Excel sheet. Then we will use this data for reporting. These are our factor loadings. So I put it here so that we can use it. These outer loadings previously copied was put here. We see the all value is above 0.6, which is recorded by Jeffen and Stewart 2005. So we do not delete any item. Then we go for constant reliability. These values we put here: front batch alpha, row alpha, composite reliability. We see they are all between the threshold level. Now we go for constant validity. First, convergent validity. It is the average variance extracted. These values we got here, and it is more than 0.5. So there the convergent validity is done. Now we say for discriminant validity. For here we have three things: kernel locker criteria. This is the one. The criteria has passed. Then we got the cross loadings. This is cross loadings. The loading is more on their themselves rather than their other construct. For this, for this, we have bold it. So discriminant validity is performed. Another characteristic is STMT ratio. This is the intent ratio. It is slightly 0.97 more than 0.90, so the decision is invalid for this criteria. But we assume that this model is valid. So our decision is this model is more or less fit for further analysis. So let's go for the next step, structural model. For structural model, we then go for calculate bootstrapping. We set up no sign, complete bootstrapping, bias corrected and accelerated bootstrapping, two-tailed test, 5% significance level, and partial square, we check path. Now we start calculation. It will take a little while. Okay, done. So we got our bootstrap results with our bootstrapping figure. This is the bootstrapping figure. We set inner model, path coefficient and p-value. We set outer model blank, and we set here absolute values. From this right side, we click export to image. The image will be exported, and we got this figure. You see this figure and this figure is same. Now we'll go for analysis. First, the model quality. The model quality is assessed based on predictability capability, which is R-square and path coefficient. We see our R-square value. This is our R-square. In the same way, we can copy it from here and put it in the Excel sheet. This is the R-square value. I have done it previously. In the same way, just repetition. So you see the R-square value is 0.73. It means 73.3% variance can be explained by education for performance, and it is statistically significant. The path coefficient, we see the beta value is 0.856, and it is statistically significant with the confidence interval. It doesn't contain 0, so the hypothesis is accepted. Now we will interpret this result. The beta coefficient sign is positive, means positive relationship between education and performance. The more education associated with better performance. The value is 0.856 with statistical significance, means 1 unit change in education could cause 0.856 unit change in performance. Based on this model, individuals should be involved more in university education, professional learning, participating workshop, taking training and gain experience to achieve better performance in their lives through high salary, good position, job satisfaction, job turnover and reward. So we find that education causes performance. This is how the smart PLS 3 works. Thanks for your time.